Have you ever wondered what the largest galaxies in the universe look like? Some of them are so enormous that they make our Milky Way look like a tiny dot in the grand cosmic scheme. You won't want to miss this as we dive into the biggest galaxies that'll make your jaw drop. But before then, let's get a quick history lesson into how we discovered them and what types of galaxies are out there. And if, for some reason, you've been living under a rock and don't know what a galaxy is, think of it as a massive, swirling system of stars, space dust, gas, and dark matter all hanging out together, bound by gravity. And before you ask, no, dark matter isn't some edgy villain from a superhero movie, though it does sound cool. The word galaxy comes from the Greek word galaxias, meaning milky. We're talking about the Milky Way, that faint, milky band of light you see in the night sky, aka our home galaxy. Not quite as refreshing as a glass of milk, but it is way more mysterious. Here's a mind-blower for you. Back in the early 20th century, astronomers finally realized that the Milky Way isn't the center of the universe, but just one of 200 billion, or maybe even 2 trillion galaxies. Yes, you heard that right. Trillion with a T, cue the mind-blown moment. So yeah, we're not as unique as we thought. And since there's so many of them, galaxies love to group up. They form clusters and superclusters, making a cosmic web throughout the universe. For example, our Milky Way is part of the Local Group, a cosmic neighborhood with over 50 galaxies, including the Andromeda Galaxy, our closest big buddy. The Local Group is chilling on the edge of the Virgo cluster and part of the even bigger Laniakea supercluster. Talk about a social network. And hey, before you get lost in the vastness of space, don't forget to like, subscribe, and hit that notification bell so you don't miss out on any more cosmic journeys. Now, galaxies aren't just star-studded shows. They're also filled with tons of space. Most of their mass is dark matter, which we can't see but can feel through its gravity. All the twinkling stars and nebulae are just the visible tip of the galactic iceberg. Galaxies can be quite the drama queens too. Some are bursting with new stars and glowing gas clouds, while others are a bit more laid back, not making new stars anymore. And let's not forget about supermassive black holes lurking at their centers. These cosmic giants can be incredibly active, emitting energy and forming quasars, the universe's most intense light shows. But wait, how did we even figure out galaxies exist? Did some genius wake up one day and say, yup, there's more out there than just the Milky Way? Well, kind of, but let's rewind. Back in the 18th century, there was this philosopher named Immanuel Kant. He had this wild idea that maybe some of those fuzzy blobs in the night sky weren't just gas or stars in our own Milky Way, but entire other star systems. He called them island universes. But hold up, the telescopes back then weren't exactly Hubble level. So for a while, those mysterious blobs were just grouped under the name nebulae, Latin for cloud. I know, super creative, right? If it looked fuzzy and spacey, it was a nebula. Now, fast forward to the 20th century. This is where things get juicy. In 1924, Edwin Hubble, not the telescope, the actual guy, used a beast of a telescope, the 100-inch Hooker telescope, at the Mount Wilson Observatory to check out the Andromeda Nebula. He looked at these stars called Cepheid variables and realized Andromeda was too far to be in our galaxy. Boom! Andromeda wasn't a nebula. It was a whole separate galaxy. This discovery pretty much flipped the script on how we see the universe. But Hubble wasn't the only one making waves. Before him, Vesto Melvin Slipher noticed that some spiral nebulae were moving away from us quickly. And that was a massive hint that these objects weren't just part of our little galaxy. Harlow Shapley and Heber Curtis also got into some serious debates about whether these nebulae were separate galaxies. Spoiler alert, Curtis was right. Thanks to Hubble, we didn't just discover that galaxies existed beyond our own. We started sorting them into different categories. In 1936, Hubble classified them into 4 main types, such as spiral, elliptical, lenticular, and irregular. Let's break it down, shall we? First up, spiral galaxies. These are the rock stars of the universe, spinning around like cosmic pinwheels. They've got a flat, rotating disk with a central bulge and those iconic spiral arms. Our very own Milky Way is a spiral galaxy, and like others in its category, it's got a starry bar at its center. So basically it's got that, I'm a galaxy, but I also work at a nightclub vibe. Now let's talk about elliptical galaxies. Imagine a galaxy, but instead of a cool spiral, it's more of a cosmic football. These bad boys can be massive, with up to 1 trillion stars stretching 2 million light-years across. But they're also pretty chill, with older stars and not much going on in new star formation. They're like the retired grandpas of the galaxy world, just floating around in galaxy clusters. Next, we have lenticular galaxies, which sit right between elliptical and spiral galaxies. Picture the iconic Sombrero Galaxy, and you've got the idea. They've got a thin, rotating disk of stars and a central bulge, but they don't have those fancy spiral arms. They're more like the hipsters of the galaxy scene. Cool, but not trying too hard. And finally, irregular galaxies. These are the wildcards of the universe, with no set shape or structure. They're like that painting you see in a museum that a kid made by splashing paint everywhere. They're still galaxies, so they're cool. Now that we're all on the same page, it's time to go over the galaxies out there that could literally swallow our entire Milky Way and still have room for dessert. Yep, we're talking about galaxies that are so huge, they make ours look like a tiny dot in comparison. First up is IC 1101, a colossal elliptical galaxy, stretching about 4 million light-years across. Some estimates even push it up to 6 million light-years. To put that in perspective, the Milky Way, our lovely home, is about 100,000 light-years in diameter. That's 2.5% this size of this monster galaxy. And if you replaced the Milky Way with this galaxy in our local group, it would swallow up Andromeda, Triangulum, and even the large and small Magellanic Clouds. It's like comparing a marble to a giant beach ball. This colossal galaxy hangs out in the Abell 2029 galaxy cluster, where it's got a massive central black hole and an interstellar medium so vast that it makes the Milky Way look like it's on a diet. Scientists love it because it's the perfect spot to study how galaxies evolve and how dark matter does its mysterious thing. This Abell 2029 cluster, by the way, spans 5.8 to 8 million light-years and is one of the densest clusters in the sky. And to show off, IC 1101 accounts for about 26% of the total light emitted by the cluster. That's a lot of cosmic bling. There's a bit of a debate about what type of galaxy IC 1101 is. Some say it's elliptical, while others think it might have a lenticular shape, depending on how you view it from Earth. But given its monstrous size, it's most likely an elliptical galaxy, since lenticular ones are usually way smaller. This bad boy is 232 million light-years away in the northern constellation of Perseus. Now, here's where it gets interesting. Rubin's galaxy isn't just big, it's also packed and seriously packed. It's got 10 times more stars than the Milky Way, making it one of the largest known spiral galaxies in the entire universe. But what's fascinating is how this galaxy looks. UGC 2885 has these super clean, smooth spiral arms wrapping around a bright core. This pristine appearance raises some major questions for astronomers. Usually, galaxies grow by smashing into other galaxies like bumper cars. But Rubin's galaxy is oddly calm. There are no signs of galactic collisions, tidal tails, or drama. It's been chilling in space, minding its own business for eons. And you know what's wild? Its supermassive black hole at the center is taking a nap. It's dormant, probably because there's not much to chow down on, like a bear in hibernation with no picnic basket in sight. The galaxy's star formation rate is also pretty low, around 0.5 solar masses per year. For reference, that's about half of what our Milky Way manages. So while we're over here cranking out stars like a factory, Godzilla Galaxy is just slowly sipping hydrogen gas and taking it easy. Astronomers using the Hubble Space Telescope are checking out the number of globular star clusters in UGC 2885's outer regions. These clusters are like the senior citizens of the galaxy, some of the earliest stars to form. If there are many of them, it might mean that UGC 2885 has been slowly gobbling up stars from smaller galaxies over billions of years, like a slow burn buffet. Here's the part where we drop some historical knowledge. Rubin's galaxy is named after the legendary astronomer Vera Rubin. She was a total game changer in the 1980s when she helped to prove the existence of dark matter, that mysterious stuff that makes up most of the universe but refuses to show itself on Instagram. Rubin's work on this galaxy helped us understand that dark matter is the unsung hero holding galaxies together. Now, here we have Malin 1, the galaxy that puts massive in a whole new league. It's so colossal that it makes our Milky Way look like a stray frisbee in comparison. This galaxy's just on another level, boasting a scale and reach that dwarf anything we're used to. Malin 1 is chilling about 1.19 billion light-years away in the constellation Coma Berenices and is known as the largest spiral galaxy in the universe. I mean, when you're a galaxy that's around 650,000 light-years wide, you don't exactly go unnoticed. That's 6 times bigger than our Milky Way. And if you think that's wild, some scientists say it might be 750,000 light-years across. Now, here's where things get a bit tricky. Despite its size, Malin 1 is classified as a low surface brightness galaxy, or LSB for short. It doesn't shine as brightly as other galaxies because its light is spread over a large area. So, even though it's enormous, the galaxy's central brightness is indeed very dim, making it challenging to observe. Want to hear something cool? Malin 1's spiral arms stretch out to 250,000 light-years, and they're extremely faint. Oh, and did you know? Despite its size, Malin 1 has a relatively low star formation rate. It's estimated to form only about 0.26 solar masses of stars per year, significantly less than the Milky Way's rate of about 1-2 solar masses per year. Let's talk about the Andromeda Galaxy, aka Messier 31, aka M31. It's the closest large galaxy to our Milky Way, hanging out about 2.5 million light-years away. Andromeda is one of the few galaxies you can spot with the naked eye. If you're in the northern hemisphere, look up in the night sky between October and December, and you can glimpse this faint, oval-shaped smudge. Here's a cool throwback. The first documented sighting of Andromeda was back in 964 AD by Persian astronomer Abd al-Rahman al-Sufi. He described it as a small cloud in his book, The Book of Fixed Stars. Now let's talk about Andromeda's looks. It's got this pancake-shaped disk with a dense core of stars and spiral arms full of younger blue stars. And get this, Hubble's telescope has spotted a double nucleus, which could be the result of past galactic merger. Here's where things get even more interesting. Andromeda is massive, about 220,000 light-years across. That's more than double the diameter of the Milky Way, and it's packed with around 1 trillion stars. That's a lot of twinkling. So yeah, Andromeda is a big deal. But wait, there's more. In roughly 4.5 billion years, Andromeda is set to crash into our galaxy. There's no need to panic though. It's like the universe's slowest car crash, leading to a new, massive elliptical galaxy. The Andromeda core houses a supermassive black hole, about 100 to 140 million times heavier than our Sun. Here's a fun fact to wow your friends. The stellar halo of Andromeda is pretty metal poor, just like the Milky Way. This suggests that both galaxies might have had similar life journeys since the Big Bang. It's like finding out that your galaxy and your neighbor's galaxy had similar childhoods. The fifth galaxy on our list is NGC 262, also known as Markarian 348. This bad boy is parked in the constellation Andromeda and is classified as a lenticular galaxy, as well as a Seyfert Type II galaxy. What's that, you ask? Well, it's like the rock star of galaxies, with an active galactic nucleus that's exceptionally bright, pumping out infrared radiation and visible light energy like it's hosting a never-ending rave. So it's got an extra bright central nucleus, but lacks those neat spiral arms that galaxies like the Milky Way flaunt. On top of that, NGC 262 is a whopping 1.3 million light-years in diameter. Yeah, you heard that right. For some perspective, the Milky Way clocks in at about 100,000 to 180,000 light-years across. Meaning, NGC 262 is over 7 times bigger. If the Milky Way were a compact car, NGC 262 would be one of those massive monster trucks. But how does a galaxy get that big? NGC 262 might be a bit of a cosmic hoarder. It's probably been munching on smaller galaxies over the eons, growing bigger with each snack. And this isn't just for show. It's got scientists scratching their heads, trying to figure out how galaxies evolve and grow to such colossal sizes. Now that you've wrapped your head around these colossal galaxies, you've only scratched the surface of the cosmic craziness out there. Speaking of which, you gotta check out our next video on the largest planets we've ever discovered in our universe. Trust me, these planets make Jupiter look small. And if you thought giant galaxies were mind-blowing, wait until you see these massive planets thriving where scientists thought no planet should survive, rewriting the rules of formation, existence, and survival. Missing out on this would be like reading the first page of a mystery novel and not finishing it. You won't get the complete picture of what's possible in this universe. So click on the next video and discover the true giants of the cosmos.